Okay, let's go over the rational exponent and radical review C. So the first one, we should be getting good at this since this is the second time through. So what we says is find the indicated nth root of A. So A is 32. And I want the nth root of that. It says 5 is the nth root. So what number times itself 5 times is equal to 32? That'll be a 2. Moving to the next one. We have the nth root of a negative 64. So I have the cube root of a negative 64. Now, because this index is odd, I can have three negative numbers would give me a negative number. It's only if I have an even index that I can't have a negative number under the radical sign. So what three numbers times itself equals 64? That would be 4. So the answer is a negative 4. Next one says simplify. That means evaluate this without using a calculator. So what I have is I have the fourth root of 625, and then I'm going to cube that. So the fourth root of 625, 5 times 5 times 5 times 5 is 625, so that would be 5 cubed, be 125. Okay, write each expression in radical form. So what I have is I have a radical, so let's put it there. The power is going to be 6. The root is the denominator, 6. The whole 10x is under the radical. That's to the 5th power. The next one, I need to take this 6, and I'm going to move it to the bottom because I have a negative exponent, so I have to the 2/3. Now my radical will be in the bottom. You can see that it's going to be a 6. The root is 3, and the power is 2. It says write each expression in exponential form. So what I have is I have 1 all over, and I have a root of 3 and a power of 5. Now I need to put this whole 6b in parentheses since the whole 6b is under the radical. So that'd be to the 5/3. And now let's bring that up to a numerator. So that would be 6b, and if I bring it up to numerator, it would have to be to the negative 5/3. The next one is I have 7, and it has a power of 4 and a root of 3. Okay, now I'm simplifying rational exponents. So on the bottom I have a negative 3/2, and I have r to the first, so those will add together. So I have 3r to the 5/3. In the bottom then I have a negative 3/2, I have 3r to the negative 3/2, and of course 1 would be plus 2 over 2. So let's simplify that. My 3's will cancel out. So I'm going to have r to the 5/3 and over r to negative 3/2. So negative 3 plus 2, that's a negative 1/2. So the larger exponent is the one in the numerator, so it's going to be the top exponent minus the bottom one. So I'm going to have r to the 5/3 minus a negative 1/2. That's going to be equal to r. Now let's go ahead and give them a common denominator. So that'd be 10/6. Minus a negative would be plus, and 1/2 would be 3/6. So I have r to the 13/6. Next one. Let's distribute the exponent in. That'd be 2 times 5/3. So that would be v to the 10/3 all over v squared. Okay, the largest exponent's in the numerator, so let's subtract the numerator exponent minus the denominator. So I'm going to have v to the 10/3, and let's change the 2 to a common denominator. So 2 times 3, that would be minus 6/3. V to the 4/3. Next one. I have x to the 3/4, and now I'm going to have to add the exponents of my denominator together. So 2/4 plus 3/4, that'd be 5/4. Now let's subtract exponents, the largest ones in the denominator. So that would be 1 all over x to the 5/4 minus 3/4. That's going to be 1 all over x to the 2/4. Now I have actually, I can simplify that to 1/2, so let's go ahead and do that. Now I have a fractional exponent in the denominator. I can't have that, so I need to get that to be a whole number. That would be x to the 1, which I'm going to write as 2/2. And so I need to get 1/2 to go to 2/2, so I would have to multiply by x to the 1/2, because 1/2 plus 1/2 is 1. If I multiply the denominator by that, I have to multiply the numerator by that. So what we'll end up with is x to the 1/2 all over x to the 2/2, and let's rewrite that as x to the 1/2 all over x. Next one, let's distribute the negative exponent in. So x to the 1/2 times a negative 2, that would be x to the negative 2/2. And a negative 2 times a negative 1 would be x squared. So now then I'm going to have x to the negative 1 all over x squared. The biggest denominator is on the bottom, so that would be x 1 all over x, and it would be to the 2 minus a negative 1. That would be 1 all over x. 2 minus a negative 1 is plus 1, so it would be 1 over x cubed. Okay, moving to the next kind of problem. I have a negative under the radical, but I have an odd index, so that works out okay. Let's go ahead and factor 375. See what that comes out. So taking a 5. That would be 75, 5, 25, 5, 5. Okay, so it's a cube root. These 3 5s are going to come out, so let's go ahead and rewrite it. Okay, so the 5 cubed comes out as a 5, multiplies by the negative 3, and that 1 5 stays underneath there. Oh, and I made a little mistake here because this is a negative and there's a negative out there. So actually what's going to come out is the negative also. So actually I should have said that's a negative 5 coming out, and I forgot to put my negative 5 like on that. So that would be change. A negative times a negative is a positive. So that would be 15 times the cube root of 5. Let's go to the next one. So now I'm going to take this and I'm going to have 3 times 3. That would be 9. And under the cube root, I'm going to have 16 times 12, which is 192. So let's find the factor tree for 192. So let's see. I have 9 times the cube root, and I have 3 2's there. I have 3 2's there. So I have 2 cubed, another 2 cubed, and I have a 3 left over. Okay, so my 2 cubes are going to come out as 2's, and they would multiply by the 9, so that's a 2. That's a 2. So I get 9 times 4, so that's going to be 36. And what's going to be left underneath there is that 3. Let's go to the next one. Okay, I have a negative 1 plus 2 times the square root of 32. So the radical stays the same and my coefficients add. So that'd be a negative 1 plus 2. That's going to be 1 times 4 times the square root of 32. Now let's go ahead and simplify that. So 32 is going to actually be, if you want to do a factor tree, 2, 16, 2, 8, 2, 4, 2, 2, so it's 2 to the 5th. And I need 2 to the, so that would be the 4th root of 2 to the 4th times 2, of which the 2 to the 4th will come out. So I'm going to have 2 times the 4th root of 2 would be my final answer. Let's move to the next one. I cannot add these as they are or subtract them as they are because I do not have identical radicals, so I need to get 64 to somehow look like a 4 over here. So let's see what 64 is. That's 2. Actually, we've done this enough. 64 is 2 to the 6th. Okay, so that's really 2 to the 4th times 2 squared. So let's go ahead and put that underneath there. So I'm going to have a negative 2 to the 4th power of 2 to the 4th times 2 squared minus the 4th root of 4. Now, we need to take this 2 to the 4th out. That'll be 2, and it'll multiply by the 2 in front of there. So I've got a negative 4 times the 4th root of 4, because 2 squared is 4. That stays under there, minus the 4th root of 4. So I have a negative 4, so 1 in front of there, negative 4 minus 1. Negative 5 times the 4th root of 4. Next one, let's take a look at these denominators. Some of them could maybe be easy to simplify. Here's one. Look at this one. They're both 4th roots. 5 divides into 10. So that's going to be 4. And now it would be one big 4th root of 10 divided by 5. So that the 4 stays there. That's 4. And now 10 divided by 5 is 2. So that'd be 10 times the 4th root of 2. Let's look at number 16. It says the cube root. And actually, I intended that to be a little simpler. I wanted that to be the cube root of, say, 27. So I'm going to change that because I wanted one that just simplifies immediately. Okay, so let's work with it like that. So even though you may not have done that on your homework, what I wanted to do is just say what you need to get you in the experience of looking for easy ones to solve first. If I would have had something like this, you would have said, oh, the cube root of 27, that's 3. So you can just change that to a 3. You'd get 5 times the cube root of 3 all over 3. Okay, and I know that's not what you got, but I want you to practice looking at the denominators. Now this one here, I have the 5th root of 27, and 27 is 3 cubed. So let's go ahead and write it like that. Okay, now we need to get the 3 cubed to be a 3 to the 5th so that it can come out of the 5th root. So I would need to multiply it by a 3 squared, and that 3 squared would also have to be under a 5th root or it would not combine. So if I did it to the denominator, I've got to do it to the numerator. All right, so what I'm going to have is 4 times the cube root of 3 squared, that's 9. And the denominator would be the 5th root of 3 to the 3 plus 2 is 3 to the 5th. So this comes out as a 3. So I get 4 times the cube root of 9 all over 5. And that can't be simplified anymore. The next one is has a radical in the denominator, but also has a number added to it. And if you remember what we have to do here, we have to take it times the conjugate, which means we're going to change the sign on the radical, multiply it by that. So minus 3 minus the square root of 2 times a minus 3 minus the square root of 2 for the numerator. So 5 times a negative 3, it's a negative 15. 5 times minus the square root of 2 is minus 5 times the square root of 2. My denominator has a negative 3 times a negative 3. That'd be a positive 9. Negative 3 times a negative the square root of 2 would be a plus 3 times the square root of 2. Now the square root of 2 is going to multiply by this negative 3. And lastly, I have a plus and a minus. This last term will always be a subtraction. The square root of 4 minus 15 minus 5 times the square root of 2 all over 9 minus 2. That would be equal to a minus 15 minus 5 times the square root of 2 all over 7, which can't be simplified, so we'll leave it like that. And I think we're at the last one. Hopefully these are getting pretty easy. Well, I have a number, and I have some numbers that have, or some variables that have exponents. So let's go ahead and take this 324. Okay, I just noticed the last one is the same that what you had on yesterday's homework, so I changed it, and this will actually be changed on your homework that you will do. So this should be correct with what your homework is that you're going to get. So let's go ahead and do a factor tree on 160. So that's going to be 2, and I'm going to get 80 out of there. 2, 40, 2, 20, 2, 10, 2, 5. So what I'm going to have is a negative 8 times the fifth root of, I have 1, 2, 3, 4, 5 2's to the fifth. That will come out because there's 5 of them, and of course that 5 will stay under. Now for, I have a fifth root in a to the 8th, so let's change that to a to the 5th times a cubed. And I have b to the 5th, so I need to take that as b to the 5th because I have a 5th power and a 5th root. That'll come out like that. And a c to the 7th, let's change that to c to the 5th, c squared. Okay, so let's see what's coming out of there. The 2 to the 5th comes out as a 2. 5 stays under. A to the 5th comes out as an a. The a cubed stays under. The b to the 5th comes out as a b. The c to the 5th comes out as a c. The c squared stays under. So when I'm done, I'm going to have a 2 times a negative 8. That's a negative 16. I have an a that came out. I have a b that came out. And I have a c that came out. And what's left underneath there is going to be this 5. I have an a cubed. And I have a c squared that are all left underneath there. That should be my final answer.